Okay, we're back on page 2 of Sample Exam Test 3A. And this page goes over a regression problem, linear regression. So on the x-axis, we have interest rate. Because it's on the x-axis, we know that's the explanatory variable, or x. And on the y-axis, we have mortgage rate. And we want to note that mortgage is in millions of dollars, and interest rate is just in percent. Okay, so this question, the first one is, what is the most likely value for the correlation coefficient? If you look at the scatter plot, you can see that there looks like, well, there's definitely a negative association. And the points fall pretty close to a straight line. They're a little bit off. But we would expect the correlation coefficient to be negative. That's obvious. And based on how close the points fall to the straight line, it's hard to tell exactly what it would be, but I would say it would be larger than negative 0.6, larger in magnitude. And so the only option that fits both of those would be negative 0.84. The association is too strong to be negative 0.2. The points fall too close to the line. And then all the other ones are definitely out of the question. All right, so the next question, we're given the regression equation. And so we're predicting mortgage rates in millions. That's why, that's the response variable from interest rate. So the first question, or the second question on this page, we want to know the predicted mortgage borrowed if the interest rate is 8%. And I'm not exactly sure why, but students like to make that into a 0.08. But you could see, if you look at the x-axis, that these are all in percentages. And so we don't transform the variable unless you're specifically told to do that. So all I need to do is substitute 8 into the equation, and I solve for y hat. So we have 2.9. I'm not sure why that first 2 is so big, but minus 7.68 times our value for x, so times 8. And that's equal to, and now the units are millions of dollars, so 161.46, and that's million. Okay, so that's my predicted mortgage borrowed if the interest rate is 8%. The next question is, suppose the last time the interest rate was 8%, people borrowed $155 million. What is the residual for this observation? So the residual, oops, I'll start over. The residual is equal to your observed, which we call y, minus your predicted, which we call y hat. Your observed value has to be given to you in the problem somewhere because it's your observed raw data. You can't calculate that. It has to be given. So that was 155. And then your predicted is whatever you got when you substituted 8 into the equation. So we got 161.46. All right, this is equal to negative 6.46 million. So negative sign there, 6.46 million. All right, the next one, this is one that students always have problems with, is writing a sentence interpreting the slope. And the slope represents how steep the line is, but we have to put that interpretation in context of the problem. So one thing to notice is that the line is negative. So that means that, the slope is negative, so that means the line decreases. And so the slope is we have a line here. The slope represents how much y decreases with every increase of 1 with x. So if x increases 1, how much does y decrease or increase? It increases, in this case decreases, by the slope, so 7.68. So for every 1 unit of x we go over, we drop 7.68. So in context of the problem, for every 1% of interest rates increase that we have, our mortgage borrowed will decrease, because the slope is negative, by 7.68, and that's millions of dollars. So I can come down here and write that out as a sentence. For every additional 1% in interest rate, the predicted amount borrowed decreases by 7.68 million. Okay, so that's how you interpret the slope. It's always for every increase of 1 for your x-axis, y will either increase or decrease by the slope. Increase if the slope is positive, decrease by if the slope is negative. All right, so the last one is saying if the interest rate increases by 3%, how much would the predicted total mortgage borrowed decrease? And this one causes trouble for students as well, because I'm not asking you to make a prediction for 3%. I'm just saying if it increases by 3%. So if it goes from 2% to 5%, or if it goes from 5% to 8%, how much would the predicted mortgage decrease? We kind of are going to use this one right here. It says for each additional 1%, it drops by 7.68. So if it does that for 1%, then 3% is just 3 times 7.68. Oops. And so we said for every 1 interest rate, the line drops don't do that. The line drops. All right, that's not going to work. We'll just write it out. I was trying to draw it out, but that's obviously not working. So since for every 1 increase of 1% is a $7.68 million drop, then we would just have 3 times 7.68, because we have 3 interests, the interest rate of 3% drop. So that's going to be in millions of dollars, 23.04. Okay, so the distinction here and this problem here is really important. Here I'm saying what is the predicted total mortgage borrowed if the interest rate is 8%. Here I'm saying if it's increased by 3%. So one, I use the line to make the prediction up here, whereas down here I'm just using the slope. Okay, so we have some more regression problems. This one has a table showing a number of years in school and salary. And the first question wants us to identify the explanatory variable and the response. So the explanatory variable always has to come first in time, and then the response variable is in response to a value of the explanatory variable. It depends on the explanatory variable. And so years in school would come before you made the big money. So years in school would explain your salary in some sense. So the explanatory variable is years, and the response variable is salary. Okay, so the amount that you make is explained by the number of years you went to school. The correlation coefficient is 0.623. Calculate R squared. Well, R squared is just equal to the correlation coefficient squared. So this problem really couldn't be much easier. I just take 0.623 and I square it. And that gives me 0.388. Or sometimes we make that a percent, so 38.3%. Okay, so now that's pretty easy. Both of those are actually pretty easy. It's the interpretation problems that really are harder for students. And so the next problem, we're wanting to interpret R squared. R squared is always interpreted as the variation. I'm going to write it generically first, and then I'll put it in context of the problem. So the variation in y that is explained by the regression equation. Or you could say your variable x, but we'll just say the regression equation. Okay, and I left something out there actually, sorry. So it's the percent of variation in y that's explained by the regression equation. And so if our value for R squared is 38.8%, so we can say 38.8% of the variation in y. Well, we need to put it in context of the problem. So the variation in salary is explained by the regression equation. Okay, so whenever you're talking about the variation in y explained by x, or the regression equation, that's R squared is what we're referring to. All right, let's go to the next one here. If you were included in the sample, would you prefer to have a negative or positive residual for your salary? Okay, so remember that the residual is equal to the observed minus the predicted. And so if your observed is larger than your predicted, then you'll have a positive residual. If the observed is smaller than your predicted, then you'll have a negative residual. I'm assuming that you would want your salary to be larger than predicted. And so if your observed is larger than your predicted, you would have a positive residual. So the answer would be positive, since this would mean that you would be making more than predicted by the regression line or equation. Okay, it's very important that when you justify this, that you use you say more than predicted by the line. You don't have to say regression, it's fine, but more than predicted by the line, because if you don't, then you're saying that you would be making more. Well, more than what? And so we want to make sure that you know what you're talking about there. And it's not always going to be positive. There's situations where you would want a smaller number, and then your residual, you would want your residual to be negative. In this case, since the variable is salary, we would want to have a positive residual. All right, so let's do this last one here. And this has to do with residuals as well. Actually, let's just end this video now, and I'll start with this one on the next video. So I'll be back.